Hey YouTube, welcome back. We often talk about throwing more hardware at a problem, maybe adding more RAM, faster CPUs, or even sharding our database. But what if I told you there is a powerful scaling technique that doesn't involve buying anything new? It's all about making your existing database work smarter, not harder. Today, we are diving deep into query optimization, which is the art of efficient asking. This is the process of improving the performance of your SQL queries by restructuring them. So let's start quite fast. First, we before I talk about this one, we need to understand that a well-optimized query can dramatically reduce its execution time, lower CPU and memory usage on your database server, and ultimately lead to much better scalability for your entire application. So we will talk about some fundamental principles, and one of them is basically, oh no, we have two examples here. You need to avoid using this. Select and store. This is one of the most common mistakes, especially for beginners. Instead of fetching all columns for table, only select the specific columns you actually need. For example, you're building a user list that only displays IDs, name, and emails. Don't ask for every single column, like select all from users. Instead, be explicit. So we need the ID, the name, the email. So we select only the three. Fetching unnecessary columns do not only waste network bandwidth, but also force database to read more data from disk than required, which is slowing down your query. Number two, unmasking efficiency. So to truly optimize your query, you first need to understand how the database actually execute them. This is where query execution plans come in. So when you use explain, for example, like most robust database systems like MySQL and Postgres provide a command like explain that allows you to see the step-by-step plan the database optimizer generate for your query. For example, you can run this command, as you can see here, which explains select all from orders where customer ID equals 1 to 3. When you run this one before you even run the actual query, basically you have some sort of analyzing plan. Like basically you're analyzing this plan is like getting X-ray vision into your database thought process, and it will tell you, for example, first if the database is performing a full table scan, like reading every single row instead of using an index. Number two, which indices, if any, it's choosing to use. Number three, the order in which tables are being joined. Number four, whether temporary tables are being created, which can be expensive. Number five, identifying these patterns is crucial for pinpointing slow joins, missing indices, or other inefficient scan operations that are hurting the performance. Okay, next we want to talk about optimizing joins, which is smart data connections. Like first, I will not talk about the index your join columns. Like this is paramount, I guess. Always ensure that your the columns you are using in your joins in your join conditions are properly indexed. Without an index, the database might restore a full table scan on one or both tables to find matching rows, leading to extremely slow performance, especially on large tables. For example, a query like this, we have or select name total from users, and we as you, and we join orders on the user ID equals user order the user slash ID, where user ID equals 1 to 3. And here is not indexed. The database will have to scan the entire orders table for each user, which is incredibly inefficient. Okay, so how you like? There's other thing that you need to think about, which is to filter before joining. Try to filter down your database as much as possible before performing the join operation. The fewer rows the database has to compare across tables, the faster your join will execute. And I guess that makes sense. For instance, if you are looking for orders from a specific customer, apply the where clause on the users table first. If that reduces the data set significantly, um, then join to the orders table. Yeah. Next, we're gonna talk about next we want to talk about batching queries, which is to reduce network overhead. For example, okay, so let's talk about this one here, which will group your insert updates. Like instead of running many individual insert or update statements one after another, which incurs a separate network around trips and transaction overhead for each. Group them into patches, for example. So instead of this, like you're doing one by one, you will use a single one here. So you patch everything at once. This significantly reduces the overhead of network communication and transaction management, leading to faster overall data loading modification. Okay, next I want to talk about when to prioritize query optimization. And you need to understand it's an ongoing process. It never ends. Query optimization isn't a one-time fix. It should be an ongoing effort throughout your application's lifecycle. The first thing, as data grows, it becomes increasingly crucial as your data volume grows and existing queries start to slow down. A query that performed fine with 1,000 rows might become a bottleneck with million or a billion of rows. Number two, when you have a high CPU memory usage. If you notice high CPU or memory usage on your database server, inefficient queries are often a major culprit. Optimizing them can free up valuable server resources. Number three, long response times. Long query response times directly impact your user experience. If your application feels sluggish due to database interactions, optimization is clearly needed. And for reducing database costs. In cloud environments where you often pay for CPU memory and I/O operations, making your query more efficient directly translates to cost saving. By doing more with less, you reduce your cloud bill. Yeah. Okay, we need to talk about some limitations and the balancing act. Like while incredibly powerful and cost-effective, query optimization also has its limitation. For example, we have diminishing returns. There is only so much you can optimize a query. At some point, you will reach a point of diminishing returns, and further performance gains will require architectural scaling techniques like caching, sharding, or read replicas. Query optimization is often about finding the low-hanging fruit and tackling the biggest bottlenecks. Number two, requires a deep understanding. Effective query optimization isn't just applying a checklist, it requires a deep understanding of your specific database engine's internals. It's a query optimizer, various indexing strategies, and how executing plans work. It's often more of an art than a science. And number four, we have number three, sorry, we have a schema changes impact optimization. If your database schema changes frequently, previously optimized queries might become inefficient or even stop working correctly. This means optimization is not a sit in and forget it task. It needs to be revisited, and potentially rewritten as your data model evolves. So yeah, query optimization is truly one of the simplest and most effective ways to scale database because it doesn't require extra hardware, just smarter queries. However, it requires a careful analysis and continuous monitoring to ensure your optimization actually improve performance without adding unnecessary complexity at your code. Okay, so yeah, in conclusion, query optimization is about asking your database the right questions in the most efficient way possible by focusing on a selective retrieval, understanding execution plans, optimizing joins, and using efficient subquery patterns. You can unlock significant performance gains without breaking the bank on new hardware. It's a crucial skill for any developer or system architecture aiming for high performance application. So yeah, that's it for this video. Thank you for watching this video and see you in future videos.